Was daily grade, yep.
Don't you have to have 70?
Everything above a 70, yep.
Can we drop something that's like 70?
Yep. Yep. That's kind of the hope, is that if you get all your corrections up to a 70, then I'll drop a 70 for you. Okay, so today we're going to talk about the substitution method. Substitution. I'm actually going to get this a little bit bigger on the screen so that we're able to see a little bit better. And what does it mean if I'm substituting something? Just not even like in math terms, but just in general. What does it mean to substitute something? Danny, what does that mean?
Put something in to replace.
Yeah, let's think about substitute teachers. Let's think about when you're baking. If you run out of an ingredient, you can substitute it for some things, right? So it says solve one equation, and we're solving for either the x or the y value. So nothing new here. We're still looking at x and y. We're solving for the x or the y value. Step 2 is we're going to substitute or replace one of those values with another equation. And then we're going to solve for the variable. Now, I know that doesn't make a whole lot of sense at this time, but I'll get there. I'm going to use this example 1 down here. Right here, do we agree that y is equal to 6x? Y is equal to 6x. So therefore, if I wanted to really make this accurate, if I say y, you should know I'm talking about 6x. And if I say 6x, you should know I'm talking about y. So when I say substitute, I'm going to take this value of 6x and I'm going to replace this y in the second problem with 6x because they're equal to each other. Therefore, by replacing this y with a 6x, I now only have one variable in the problem. Okay? Step 3, we're going to solve your answer, write your answer into the revised equation from step 1 and solve for the other variable. So let me read that out loud to you one more time and then we will get started. It says solve one equation for x or y. It does not matter which one you choose. Step 2, substitute this expression into the other equation and solve for the variable. Step 3, write your answer into the revised equation from step 1 and solve for the other variable. So again, you can copy down as much of that as you want. You don't have to do all of it, or you can. It makes no difference to me. Just want to make sure you guys feel good about that. This is actually a pretty strong lesson. I think you guys will feel good about it after you see it. It's just one of those ones that takes a little bit of time to kind of master. We'll get there. Can I move on, or are we still writing? Okay, cool. We're learning this.
Oh yeah.
It's not too bad when you get the hang of it, but it just takes a little bit. It's uncomfortable.
It looks pretty easy.
It looks what?
It looks pretty easy.
It is. I think it's just kind of one of those things when we see more variables, just like when we see fractions, our bodies tend to tense up and get nervous, and therefore we don't want to think about it. We just go, I don't know what to do. Case in point, the warm-up this morning that no one did until I made it mandatory, right? If we felt comfortable with it, we at least would have tried it, but we all just kind of froze. And I get it. It's hard. I get it. Can I move on?
I think everybody in the world hates fractions. No. Especially the first time.
What?
You know, the interesting thing about fractions, in my opinion, is once you understand how fractions work, they're actually easier than decimals, as far as simplifying numbers. But I would still choose to do a decimal over a fraction 10 out of 10 times.
Yeah.
I was tutoring someone yesterday for the SAT, and there was a problem, and I was looking at it, and he wanted to convert everything to fractions, and I was like, I don't know if I can solve that as fractions, and I converted them all to decimals. We got the same answer, but it took him twice as long as it took me to do it, but it made sense to him, so I was cool with it. Okay, so right here, everybody, we are given that y is equal to 6x. That means they're equal to each other. It's kind of like if I say Brian or Segovia, we know who I'm talking about, whether I call him by his first name or his last name. Agreed? If you call me Ryan, if you call me Paber, I know who you're talking to. We're all okay with that. So what I'm going to do is I'm going to substitute in this value of 6x in for everywhere that I see a y. And so when I rewrite this problem, it's going to be 2x plus 3 times 6x is equal to a negative 20. Thank you. Okay, look at that for a second. I know you're writing it down. Look at it, see if you understand what I did. Don't just say yes so I can move on. Do we understand why I was able to replace this y with 6x? Would somebody be willing to tell the class why I was able to do that for me? Steven, go for it.
It just says y equals 6x.
So if y is equal to 6x, they're interchangeable. Yes, AJ.
Did you just, because if y literally does just equal 6x, then you can replace any instance of y in it with 6x and this will make sense.
Absolutely, yes, 100%. Are we all on board with that? All right, I'm going to move forward then. Y'all, this is just an equation. This is unit 1. All we have to do is combine like terms and solve for the variable. Are we okay with that? Let's think back to order of operations though. These are being multiplied, so can I multiply them together?
Yes.
Even though one has an x and one does not, because I'm multiplying, it's okay. So here, if I rewrite this problem now, I'm going to have 2x plus 18x equals negative 20. Are we okay with that first step? Okay, Zoe, be bold. What do I do next? Yeah, so now I have 20x is equal to negative 20. What's my final step here? What's my final step, Colin? Divide both sides by 20. And we find that x is equal to a negative 1. That's great. So excited and proud of you for solving for x. That's exactly what we just did on the warm-up. Do we agree? We're all good with that. However, only having an x does not help me in any way, shape, or form if I'm trying to graph something. Remember, we're trying to find what is that one intersecting point where the two lines cross. You guys follow what I mean by that? From Monday, we're trying to see where do these lines cross. So what do you think I need to do now that I have a value of x? JC, what do you think?
Plug it in.
I'm going to plug it in. What are we trying to solve for now? Y. So if I come over here, I already have y equals 6x. If I rewrite it, I now have y equals 6 times a negative 1. Are we okay there? And if I do 6 times negative 1, we find that y is equal to negative 6. And so my ordered pair is negative 1, negative 6. Okay, I'm going to ask this question. I'm asking this truly. Where are we stuck? Where are we confused? Where did I not explain well? Where did I go too fast? In my mind, all these are skills that we already know, but I'm also not an 8th grade student. So if there's something you're not getting, please let me know. You're not going to hurt my feelings. Ian.
Can you go over the right side? With
Yeah,
the
sure. So I solved for the x. Are you okay with how I got the x value? So then what I did is I said I want to get the ordered pair. And so I need to solve for y because we know that x, y always makes an ordered pair for a graph. And so I took the value of y, which happened to just already be in y equals. It gave it to me in a very easy way. And I replaced the 6x with 6 times a negative 1, which was the value of x. So basically what I did is, just like I substituted 6x for y, I'm now substituting negative 1 for x. I'm just doing the same thing for this other variable. And then I solved it out and found that 6 times negative 1 is negative 6. Does that make sense? Connor.
So why wouldn't y be negative 6?
Why wouldn't y be?
Oh no, wait, never mind.
Y is negative 6.
It took me a second.
Okay, you're good. Brian, you have your hand up? No? Okay. Easy enough? Okay. Okay, let's try number 2. Now, notice on number 2, it's giving me the y value again. So which one do you think I should go ahead and plug this in for? Plug in for the y. You don't have to. You can make your choice. We'll talk about that for number 3. What I'm going to do is I'm going to take the y, which is equal to x plus 9, and I'm going to input it for the y in this second problem. So now I'm going to have 3x plus 8. Now, the way that I'm going to write it, and this is just how my brain works, is I'm going to put it in parentheses. So I'm going to have x plus 9 equals negative 5. Yeah, what's up, Connor?
Just really quickly, can you go over why, or like what you did? I didn't understand
At number 2 or number 1?
Number
So y is equal to x plus 9 in the first equation. In the second equation, I have the y value right here. And so what I did is instead of writing 8 times y, I replaced the y with what y was equal to, which was x plus 9. So literally all I do is I remove that y and I replaced it with an equal expression of x plus 9. Other questions? Great questions. Now we just solved it. Now we're going to have 3x plus 8x plus 72 equals negative 5. Everybody okay with how I got to that step? Okay. Anybody not okay with how I got to that step? Can I do 3x plus 8x? That's going to give me 11x plus 72 equals negative 5. Can I do 11x plus 72?
No.
So what do I need to do with that? What do I need to do with the 72? What do I do with it?
You add it to negative 5?
Not add it,
Oh, you subtract it.
subtract it. So now I have 11x equals negative 77. Which the number 77 is such a good number. Anybody tell me why 77 is such a good number? Carter, why?
Luca.
Yes, Luca. Okay, what's my final step here? Zayden, what do I do?
Divide both sides by 11.
Both sides by 11. X equals negative 7. What's up, Carter?
So how'd you get to the distributed property part, like at the, on the second, at the first time you're solving it, the top?
Okay, so do you agree that are you okay with how I replaced the y with x plus 9? Are you okay with that step?
Oh, I see, yeah.
I put it in parentheses just to show what I'm physically putting in there. If I was going to describe it to someone, I would say these parentheses are like handlebars, and I'm literally grabbing that expression and I'm putting it into the next equation. I know it's kind of cheesy, but that's just how I would envision it. Those are handlebars, and I'm physically moving them and replacing them in somewhere else. Does that make sense? Okay, other questions? Great questions. I love these. Okay, so now what do I need to do next? What's my follow-up step to solve this problem? Hayden.
Input negative 7 in the fourth equation.
Yeah, so watch. I'm going to have y equals x plus 9. Now I'm going to substitute in a value for x. And I know that x is also equal to negative 7. So y is going to be equal to negative 7 plus 9. So y is going to be equal to a positive 2. Yes, Stephen.
So whenever you put it down in parentheses, do we have to do that? Because if we don't put it in parentheses, wouldn't it just be 8x plus 9?
Yes, then you'd have 8x plus 3, which is 11x plus 9. But then if you subtracted 9 from both sides, then you're going to get something different. And so the reason I want you to do that is because the y is being multiplied by 8. Do you agree with that in this first statement up here, 8y? Because since I don't know what y is, I know I'm multiplying by an unknown number. Are you with me there, Stephen? And so since I'm multiplying by an unknown number, I still have to multiply this 8 by the numbers in the parentheses that I've added to them. So yes, it would have to be put into the parentheses. Xavier.
So how I see it is you do some simple PEMDAS with variables, and then the answer you get at the end you plug in for x to solve for the y.
Correct.
Okay.
Hey.
Is there a way to check the walk?
Yeah, absolutely.
We can just input it to the first or second equation.
You could, or I can even give you an easier way shortly. I'm not willing to reveal that secret yet, though.
Oh.
Yet.
Yeah. How am I doing on time here? Ooh, man, lucky.